Hello everyone. So in today's video we are going to learn evaluation of any integral using Green's theorem. So first of all, what is Green's theorem? Green's theorem is the relation between line integral and surface integral. And sometimes we are not able to evaluate line integral, so we can change that line integral into surface integral using Green's theorem, and vice versa. If we are not able, if we have to evaluate any surface integral and by that traditional methods, if we are not able to integrate that, we can change it to line integral using Green's theorem. Okay, so let's start with the statement of Green's theorem. So I have written the mathematical expression here. If you understand this properly, you can write the statement. So what is there? That we can see a line integral is given of the function m dx plus n dy is equal to surface integral or double integration of dou n by dou x minus dou m by dou y dx dy. So reading this mathematical statement only, how we can write? Whatever the terms are given here, we have to define that. So let's say R is any closed region bounded by the closed curve C. So if C be the closed curve C, then this is R. So R be the closed region bounded by the closed curve C in xy plane. This is x and y terms only. So this region lies in xy plane. So R be the closed region bounded by the closed curve C in xy plane. M and n are the continuous functions of x and y such that partial derivative, first order partial derivative of m and n, dou m by dou y, dou n by dou x exist and are continuous in the region R. Then by Green's theorem, line integral of m dx plus n dy is equal to surface integral over R dou n by dou x minus dou m by dou y dx dy. So this is the statement of Green's theorem. So for evaluation, we have to use this mathematical formula and we have to apply to the given integral. So let's start with the first example. First example says evaluate this line integral using Green's theorem where C is the boundary of the region enclosed by these two curves. So whenever any question says something, we have to write the statement for the required theorem. So for this, we have to write the statement of Green's theorem which says that C m dx plus n dy is equal to integration over region R dou n by dou x minus dou m by dou y dx dy. So first we have to write the statement for Green's theorem that we have written. Statement means that mathematical expression itself is sufficient. Now let's trace the region R over which we have to integrate. So as we have done in double integration part, let's trace the given curve. So first curve is y is equal to root x. Y equal to root x means y square is equal to x. So y square is equal to x is the parabola this. Y square is equal to x. And second curve is y is equal to x square, which is upward parabola. Now what is the enclosed region? This leaf. So what may be the coordinate? This is origin 0 0, and if we solve these two equations, this is y is equal to x square curve, this is y square is equal to x curve. So if we find out the intersection point of these two, that comes out as 1 1. So we have to integrate over this region. Now how we integrate over any region? We take any vertical strip and we see how it is moving. So at the bottom of the line, what is the equation of curve? Y equal to x square. So it starts from y equal to x square and it goes to upward curve, which is y square equal to x. So I can say y equal to root x. And then x varies from 0 to 1. So what are the limits? That limits are y is equal to x square to y is equal to root x, and x is varying from 0 to x is equal to 1. We can take the horizontal strip also and can take the limits accordingly. Now let's change the given integral. So given integral is, so from given integral, we can say that what is the value of m? If I compare this value with the given question, what is the coefficient of dx? That is m. So that is 3x square minus 8y square. Similarly, n will be coefficient of y, that is 4y minus 6xy. Now change it to right hand side, we have to find out partial derivatives. So what is dou m by dou y? Dou m by dou y is minus 16y and dou n by dou x is minus 6y. So what is the value of dou n by dou x minus dou m by dou y? This is equal to minus 6y minus of minus 16y, that is 10y. So that value we have calculated. Now we have to simply substitute the value and the limit and we have to integrate. So let's integrate it further. So I have written the statement. This is the given integral in the question, and which using the Green's theorem reduces to the form of double integration over the region R 10y, which we have calculated from here, dx dy. Now let's substitute the value of limit. So limit is varying from, y is varying from x square to root x and x is varying from 0 to 1. 10y. Now what will be the order of integration? First we are going along y axis, so dy and then dx. So 0 to 1, integration of 10y square by 2 x square to root x dx. So this is 5, 0 to 1. If I put upper limit, that becomes x. If I put lower limit, that becomes x4 dx. So 5 x square by 2 minus x5 by 5, 0 to 1, which is equal to 5, 1 by 2 minus 1 by 5. So 5 minus 2, 3 by 10. So this is equal to 3 by 2. So this is the value of this line integral over this region R. So if we go along the curve and we find out the line integral, that is equal to this value only. So that is the use, that is how we evaluate any given integral using Green's theorem. So I hope this is clear, and you please keep practicing the similar questions. See you in next video for the next theorem. Thank you.